Well, guys, now things are going to get more complicated. Okay, I'm just going to throw a bunch of formulas your way. That'll be the hyperbolic sine of x, hyperbolic cosine, the hyperbolic tangent, right? And then you have the hyperbolic cosecant, secant, and cotangent. Now you have this, all right? That'll be the inverse hyperbolic functions. You get all these domains in here because because these are the reverses, right? That'll be the inverse of the hyperbolic sine, the inverse of the hyperbolic cosine. So in order to have an inverse, you gotta have a one-to-one from x to y to be a function, and from y to x to have an inverse function. So if you have two y's for each x, or more than more than one y for each x, you're not going to have a reverse anymore. So I have all these domains in here to restrict the part of the hyperbolic sine that actually does have an inverse. The part of the hyperbolic cosine, tangent, cotangent, secant, cosecant, all these things that have an inverse, you got to restrict the domain in here. Except the hyperbolic sine, right? For it to have an inverse, you have from minus infinity to infinity, so no restrictions at all. I don't memorize this stuff. I try to memorize a little these things in here, but unless you use them constantly, you're not going to be able to memorize them. That's why we have integration tables and integration calculators to do all these things for you, but yeah. Okay. Now, there's some special integration formulas. I'm going to let you guys pause this. Well, let me see here. Maybe here. And then you got this. Yeah, it's a bunch of formulas, I know. It's overwhelming, right? So pause that video, copy, take a screenshot of it, because I'm going to erase all this stuff. Okay, so here, these things you just have to memorize them. Integral square root of 1 minus x squared dx. Okay? Well, that'll be half, be pretty much it. Gonna be half of, I'm gonna put a big, I was gonna use 2 halves, but no. It'll be half the arc sine of x plus x, and you just repeat that square root, 1 minus x squared. It'll be the square root of 1 minus x squared, okay? Then you have the integral of 1 plus x squared dx, right? And it's going to be half. I'm going to do something similar. So this is going to be, you can say x, the square root of 1 plus x squared. It's getting too tight. The square root of 1 plus x squared, right? Plus this inverse of the hyperbolic sine. Now remember, inverse of the hyperbolic sine was going to be, inverse of the hyperbolic sine was going to be of x, right? This is of x, was going to be, not half. It'll be the ln of 1 plus the square root 1 plus x squared. Okay, so you just plug that stuff. Oh, not 1. Man, I'm sleepy. Of x. So you just plug that in here. Okay, this, of course, this thing here is also the inverse of the hyperbolic sine of x, right? And you can see, from that special integration, this thing here is going to take the format of, I'm just going to put it here. Well, okay, I'm just going to put it here. It'll take the format of the square root. I don't know why my square root is coming out like this. Of the square root of u squared plus a squared, right? Du. And this will be half times, gotta put everything in half, so I'm just gonna put that in there, okay? And then you have u, well, you have, yeah, u square root of u squared plus a squared plus a squared ln of u plus square root of u squared plus a squared, right? Of course, you have to put this in absolute value. I'll put the absolute value here. Outside, should be inside, but oh well. Okay, now in this case here, the a squared is just going to be a 1, okay? So you're knocking out this stuff. Yeah, no, not the u. The u is going to be x, right? The u squared is the x squared. So in this case here, the u is going to be x, and the a is going to be 1. So when you have a squared, you just knock it out, okay? And you can see that it's just the same thing. It'll be half u times u squared plus a. Well, the u is going to be x, right? And the square root of u squared is going to be x squared plus a squared is going to be 1. And plus this thing here. But this thing is the hyperbolic sine. Okay? It's just that, well, the reverse of the hyperbolic sine. It's not u, it's x, right? You have ln of x plus square root of u plus 1 plus x squared. And the 1 is just going to be the a squared. So we're just, you got to put all these things together in your mind, and it's very hard. Especially when you're sleepy. So I'm going to erase all this. And just for completeness, I don't know if you're going to be able to see this thing. You have this stuff, okay? The graphs of the hyperbolic functions, right? Hyperbolic trigonometric functions. I don't memorize these. And now we're going to see some identities. For example, the sine squared of x, okay, I'm just going to sine squared plus cosine squared equals 1, right? But when it comes to hyperbolic sine, why is this 1? I just want to show this for people that don't know. So you got something in here, and then you have something, oh man. Okay, and now you have something here, like that, okay, where the radius is 1. So you have something that's going to be from here all the way there, all right? So what do you have? You have this distance and you have this distance, okay? Well, what is this thing right here divided by the hypotenuse? It's the cosine, right? So let's just say that this is x, the angle is x. So what's going to be the sine of x? It's going to be equal to this distance divided by the hypotenuse. So let's just put this a and this one b and the hypotenuse h, but the hypotenuse is 1, so forget it. So it's going to be a, right? The cosine of x is going to be this distance right here, this is the b, okay, divided by the hypotenuse, which is just 1. So you got a right triangle in here, okay? So if you have this squared plus this squared, you have a 1. So that's where this identity comes from the unit circle, right? It's going to be a squared plus b squared equals the hypotenuse squared, which is 1. So that's where it comes from. All right, now let's think about something else here, which is the hyperbolic. When it comes to the hyperbolic, cosine squared of x minus sine squared of x equals 1. All right. Now let's go after that stuff. You have, it'll be the cosine, the hyperbolic cosine is going to be e to the x, right? It's e to the x plus e to the minus x divided by 2. So let's try that. You're going to have e to the 2x, because it's squared, right? Plus 2 times e to the x, e to the minus x. Now here's the thing. When you have the same base, what's going to happen? You're going to add the exponents. So x minus x is 0. So this is just going to be 1. Okay. So you can say like plus 2, right? Plus e to the minus 2x, and divide this whole thing by 4. And then you have a minus. And over here is going to be the same thing, like e to the 2x, but this time it's going to be a minus 2. Because the hyperbolic sign, you have this as a minus. It's going to be minus 2 plus e to the minus 2x divided by 4. So here's the thing, it's minus this whole thing, okay? So let's just change the sign here. Minus with a plus, minus, minus with a minus, plus, minus with a plus, minus. Okay? So you have e to the 2x, e to the 2x, this is going to be 0. E to the minus 2x minus e to the minus 2x, these two cancel. 2 plus 2 equals 4. Okay, because I already took this, you see, when I change the signs in here, I also had to change this one. So it's 2 plus 2 equals 4 divided by 4, which is 1. So this identity here, it's proven. Okay. You got some other identities that are proven too. Just one more. You have 2 hyperbolic sine times the hyperbolic cosine. Gonna be the hyperbolic sine of 2x. So you gotta admit that, not admit, but you just gotta assume that all this is x. So here you have from an angle formula to a double angle formula, okay? So if you multiply those things, you're gonna be able to see it like, I'm gonna get, well, I'll do it. So twice, and here you have like that. So e to the x minus e to the minus x divided by 2 times e to the x plus e to the minus x divided by 2 Okay, so this, and this, they form that thing, okay, that is a plus b, a minus b equals a squared minus b squared. So this is going to be equal to 2 times, oh, I'm going to make this, I'm going to forget about this thing. Just cancel these two, right? So this doesn't exist anymore. And now you have the square of the first minus the square of the second. It's going to be equal to e to the 2x minus e to the minus 2x divided by 2. Well, this thing is the double angle formula, okay? So instead of plugging an x in here, you plug a 2x in there. And here you have, so this is going to be the hyperbolic sine of 2x. Okay, so I'm going to show some more trigonometric identities here for all that. A lot of formulas, right? Let me just, no. Yeah, this is going to be better. So you see, you have something that says, you have a little bit of symmetry. So cosine squared plus sine squared is going to be equal to 1. Here's cosine squared minus sine squared. You got another identity that says 1 plus the tangent squared equals the secant squared. So now you have the tangent squared plus the secant squared equals 1. Okay, so it's not so much off. And if you change the tangent to cotangent and the secant to cosecant, you change the plus to a minus and you still get the same one. All right. This one here is pretty much like the other one. For example, if you have sine of x plus y is the same as sine of x cosine of y plus cosine of x sine of y. So you have pretty much the same thing here. And here you have the same stuff, sine of x cosine of y. Okay. This one here is the only thing that changes from the non-hyperbolic. This one here, it's this plus sign, which is supposed to be a minus. Okay. When this is a plus, this is supposed to be a minus in the non-hyperbolic. So in the hyperbolic, you keep the sign. All right. On this one here, in the non-hyperbolic, you know that the sine squared of x equals 1 minus cosine, okay, sine squared of x equals 1 minus the cosine of 2x divided by 2. Okay. In here, instead of changing, all you got to do is change from this to from plus to a minus and from this minus to a plus. If you change that, you're going to get the same stuff. So you see that's not that off. It's a little bit, yeah, it's many things to memorize, but it's not that much off, okay? This one here is exactly like the one of the non-hyperbolic. So is this one. And this one here, from the non-hyperbolic to the hyperbolic, you change from a minus to a plus, okay? So, yeah. But it is a lot of formulas, guys. I give you that. A lot of stuff to memorize. Yeah, I'm gonna show you something else here, like that, more formulas. Yeah, that's the unfun part of mathematics, right? When you have to memorize all this stuff. But hey, but like I said, it's not that much off. For example, this derivative of the sine is going to be the derivative of the cosine. The derivative of the cosine is minus derivative of the sine. So again, you're changing from a minus to a plus. All right. The derivative of the tangent is the secant squared. The derivative of the cotangent is the minus cosecant squared. Yes, it's the same for the hyperbolic and non-hyperbolic. For the secant, it's going to be secant tangent, but because it's hyperbolic, then you have to change this from a plus to a minus. And the cosecant doesn't even change anything. If this were non-hyperbolic, it would be the same stuff. Okay. So let's show a few proofs in show a few proofs in here. This is going to be a short video, or maybe because it's not too much fun. I mean, it's not me explaining, it's just you guys memorizing. Let's find the derivative of the hyperbolic sign. E to the x minus e to the minus x divided by 2. So I'm just going to put this 2 as a half in here. I'm going to put it outside. Right? So you have this stuff in here. Okay. So you want the derivative of this. Okay. Derive this. Just take the derivative with respect to x. So it's going to be half. Now what is e to the x? It's e to the x. Okay. But remember guys, it's e to the x times the derivative of this one. Okay. Because the e is going to be, even though it's weird, the e in here is the outer function and the x is the inner function. Right. So you're taking, because you're not taking the derivative with respect to e. You're just taking the derivative with respect to x. So it's e to the x times the derivative of this, which is what? 1. Now you got a minus, right? And then you have e to the minus x, which is going to be what? E to the minus x times the derivative of this, which is what? Minus 1. So you see in here you're going to have a minus e to the minus x. With this minus becomes a plus. So make this a plus. Erase this thing in here, and guess what you have? E to the x plus e to the minus x divided by 2. This equals the hyperbolic cosine. Okay, so that's a proof in there. Taking the derivative of this to show that it's the hyperbolic sign, not the minus hyperbolic sign. Let's do that. So you have half. Taking the derivative of the first one is going to be e to the x. Plus, taking the derivative of the second one is going to be e to the minus x times the derivative of that, which is minus 1. So when you do that, you change this plus to a minus, and there you go. This is the hyperbolic sign. Let's do some exercises now. Find the derivative. Find the derivative of that with respect to x. Well, it's going to be the cosine, hyperbolic cosine of x squared minus 3 times 2x. Right? That was nice. That was easy. Now take the, come on. ln of the cosine of x. Okay? Take the derivative of that with respect to x. So it's going to be 1 divided by the cosine, the hyperbolic cosine of x, times the derivative of the inner function, which is what? The hyperbolic sine of x. So you have hyperbolic sine divided by the cosine. This is the hyperbolic tangent. So the integral, see, the integral of the hyperbolic tangent equals ln of cosine of x. But hey, the integral of the tangent is what? Minus ln cosine of x. I don't know if you guys remember this. So you see, it changed instead of being a hyperbolic. When you go back here, what do you have? You have a plus. Okay, non-hyperbolic, when you come, what do you have? You have a minus. So it just changes. It's the same formula, except that it's from a plus to a minus. Now, I'm almost finishing this video. You guys already had a lot of content to worry about because too many freaking formulas. I was actually feeling sorry for you guys. That's why I didn't do this sooner. I don't know if you'd noticed, but I think that I stayed 1 day or 2 days without posting any content because I was like, oh, these guys are not going to like this. They're going to have way too much stuff to memorize. Well, here you have the product differentiation, right? So we have to do sine of hyperbolic x plus x cosine of hyperbolic x, and then you have minus sine of hyperbolic x. Yeah. Well, yeah. The book keeps going. So you have hyperbolic x minus, sine of the hyperbolic x minus. So you cut all these, and the only thing that you're left with is this. Let's see something else in here. Find the relative extrema of f of x. So have x minus 1 hyperbolic cosine of x minus hyperbolic sine of x. In order to find out the extrema, you gotta differentiate this stuff. Let's do it. And here is just gonna be 1, okay? The derivative of this is just 1. So it'll be a hyperbolic cosine of x plus x minus 1, the hyperbolic sine of x, all right, minus the hyperbolic cosine of x. That's the derivative. Now, you see, you have hyperbolic cosine of x minus the hyperbolic cosine of x. This is just you're gonna cut these two, and you're left with this. Now, when is this gonna be 0? Well, it can be 0 when x is 1, okay? Because you see, what is the hyperbolic sign? E to the x minus e to the minus x divided by 2. This is the hyperbolic sign. So let's make this 0. First, let's worry about this part. So when x equals 1, yeah, that's 1 minus 1, 0, so knocked out. Now, hyperbolic sign, what value do we put in here to make this thing a 0? A 0, right? Because it'll be e to the 0, that's 1, minus e to the minus 0 is just 1 divided by e to the 0, which is 1, and 1 minus 1 divided by 2 is going to be 0. So, here. So, at x equals 1 and at x equals 0, this is going to be 0. Okay. So it's saying here, using the second derivative test, you can verify that the point 0 minus 1 yields a relative maximum. That means that the concavity is down. In point 1 minus sine of hyperbolic 1 yields a relative minimum. as shown in the figure. Okay, so I'm already going to show you the figure. So it's the same thing, guys. What you want to do, you see, this right here, this, okay, is going to be some kind of maximum. And because the second derivative over here is going to be negative, you know that it's concavity down, right? At some point in here, the first derivative is not going to be 0, but the second one is going to be 0. So you know that this is a point of inflection. And from this point on here, the concavity is up. Okay, and here you have a first derivative of 0. Okay, and the second derivative here is going to be positive, showing concavity up. So you got to break this down kind of like in here. Let me put it this way. Okay, see? All right, so here's the point of inflection. This is concavity down. Here you got the second derivative. At this point, first derivative 0, second derivative negative. At this point, first derivative 0, the second derivative positive. This is concavity up, this is concavity down. Where the vertical line is passing through in here is where the first derivative is different from 0, but the second derivative is 0, which means you have a point of inflection there. I think that'll be it, guys. Yeah. We're going to continue this on the next video.